Before we get launched, let me go through a few housekeeping items that apply to all the narrated lectures. The narrated lectures generally follow the mini cases at the end of each chapter. To better follow along, you might want to print the mini case from your ebook or have it open. All the calculations in the textbook chapter are available in the chapter Excel file called the Toolkit. The toolkits for each chapter are posted in Blackboard in the unit module folder as well. So let's get going. This is part A of a 4-part set covering Chapter 4, the time value of money. I expect and hope this will be a review for you all. Time value of money is one of the most important concepts in finance. The truth is, most of the rest of the material we'll cover is based in some way on TVM concepts. As we cover the chapter topics, I'll also briefly cover solving TVM problems in the TI Business Analyst 2 Financial Calculator and in Excel. The PC1 TI BAII Plus intro video tutorial provides a more detailed introduction to the TI. Using the TI TVM keys, solving TVM problems using standard calculator keys, and the use of the TI Business Analyst 2 cash flow worksheet are covered in 3 video tutorials, A1, A2, and A3, posted with the unit. I strongly recommend you review PC1 before attempting this chapter. The other 3 either as or after you go through Chapter 4. Starting with the time value of lump sums, we'll look at future values, present values, and rates of return. Timelines may seem pretty basic, and when dealing with straightforward cash flow streams, they may not be needed. But when the cash flow stream is in any way unusual, using a timeline can be very helpful. Time 0 on the timeline is now, today. Time 1 is the end of period 1 and the beginning of period 2. We always assume cash flows occur at the end of the period unless we are told differently. We typically think of the period as a year, but it may be a quarter, a month, a day, whatever. The percentage on the timeline is the discount rate. Note the use of CF. Using CF to indicate the cash flows implies that the dollar values are not the same each period. If they were, we'd have used PMT, payment, which we'll address in a later segment. Note, inflows on a timeline are shown as positive values, outflows as negative. The determination is whether it's an inflow or outflow to you. As the mini case asks, this shows the timeline for $100 to be received in 2 years when the discount rate is I%. The diagram makes it clear that to find the present value of the $100, you need to discount it back 2 periods. In this case, the timeline shows an annuity of $100 to be received every year for 3 years. If we were to show this timeline generically, the $100 would be replaced by PMT, payment. This timeline demonstrates the type of cash flow stream we'll typically be dealing with in this class. A set of uneven cash flows beginning with an outflow followed by a series of positive inflows. Remember, negatives are an outflow from you. It could be a payment made on a loan or money you put into an investment. If it's going out of your control, then it's an outflow. The question is, what is the future value of $100 invested today at 10% interest per year if you leave the money invested for 3 years? Most studies of time value of money begin with the future value of a lump sum, since this is the most intuitively comfortable use of TVM concepts. Quote, put your money in a savings account and leave it and it'll grow, unquote. This is the power of compounding, earning interest on previously earned interest, which we'll explore in the next few slides. In the first year, your $100 will earn $10 in interest, so at year end, you'll have $110. In the second period, you'll earn 10% on your previous balance of $110, so your new balance is $121. By the third year, you're earning interest on your original $100 plus the interest earned and the interest earned on that interest, total $133.10. This solution uses the general formula. It has 4 variables. FV is future value, PV is present value, N is the number of periods, I is the interest rate. There are 4 ways to solve the general formula. Step by step using the timeline, using a regular calculator in the formula, using a financial calculator, and using Excel. We're going to focus on the last 2 as being the methods you'll be most likely to use. If you're new to the TI BAII Plus, take time to view the TI BAII Plus intro video before going further. Also, you might want to check out practice assignments in MindTap for the TI Business Analyst 2. Starting with the financial calculator approach, let's get all our calculators set up correctly. I find setting the number of decimal places displayed to 4 gives you sufficient precision without cluttering the readout. Follow the instructions for the BA2+. The second key is near the top on the left and it's a different color. The format key is the second use of the period key, center bottom. You must press the enter key, top row, to change the number of decimals to 4. Once set, it'll stay 4 unless you change it or reset the calculator to the defaults. This is demonstrated in the video tutorials. We need to be sure the calculator is set to use algebraic operating system. AOS follows the order of operations rules in solving equations. Again, follow the on-slide instructions. End, meaning cash flows occur at the end of each period. This is the default setting, but we need to be sure that's how your calculator is set. The BGN key is the uppercase of payment, third row, fourth key. This acts as a toggle between end, nothing in the upper right corner of the display window, or begin, which will display when it's set. Second and set toggles between end and begin. Be sure you're set to end before quitting. We also need to be sure your P/Y, payments per year, is set to 1. Finally, how to clear the calculator. When you enter values in any of the worksheets or in the TVM keys, N, IY, PV, etc., they stay there until you clear them or overlay them. This can be a plus if you're doing repetitive calculations using some of the same values. Other times, not so much. You can clear the TVM as shown above or simply always enter something, like a 0, in 4 of the 5 variable keys. With the built-in worksheets, you must clear them as you may not know how many values were entered the last time you used it. Most of these settings are covered in the intro and TVM video tutorials. Back to the basic formula. 4 variables. We're not using payment yet. You can algebraically solve for any one given the other 3. Your calculator does the same. At this point, simply enter 0 in payment, enter the other variables, then press CPT, compute, and then press the key for the variable you wish to solve for. Here's the calculator solution to our $100 invested at 10% for 3 years. Notice that since the $100 was invested, that's an outflow, so it needs to be negative. To enter a negative number, you need to press 100, then the plus or minus key at the bottom right, and then enter it in the variable. Also note that the interest rate, 10%, is entered as a whole number, 10. Just to be sure we all have everything set correctly, be sure you can do this simple problem in your calculator and get the correct solution. Naturally, Excel has a financial function for future value, FV. Accessing the function through the FX key at the top brings up a window where you can enter the values or, preferably, point to the cells containing the values. Note that in Excel, the interest rate is entered as a decimal. 10% is 0.10, whereas in your calculator, 10% is entered as a whole number, 10. Okay, we're done with compounding. Let's go to present value and discounting. Our problem is, what's the present value of $100 to be received in 3 years if the discount rate is 10%? Remember why it's worth less today. Because it's risky, it's out in the future. Because if you had it today, you could have invested it, so it's worth less today. We could simply algebraically solve the general equation for present value and plug in the numbers. Note, the y raised to the x key on your calculator is what allows you to perform this calculation. Enter 1 divided by 1.10, hit y to the x, 3 equals times 100. Solving this type problem without using the TVM keys is covered in the TVM by hand video tutorial. Here's the same problem solved in your calculator using the TVM keys. Note that in your calculator and in Excel, either present value or future value must be negative. You either have to invest money now, negative present value, to receive money in the future, positive future value, or vice versa. If neither are negative, you're going to get an error. The negative answer means that if you invest $75.13 today at 10%, in 3 years you'll have $100. Again, Excel has a PV function. Use it like the future value one, and examples are in the video tutorials. While TVM usually does revert to money, it can be used with other variables as well, anything numeric. As with present value, we can algebraically solve the basic equation for N and find how long for a specific growth to occur. We want to find how long it will take for a company's sales to double if the growth rate is 20% a year. You don't need to know what sales are now. Double is just 1 to 2. In this case, the algebraic solution is 3.8 years. Note, the natural log key, ln, is in the far left column on your calculator, and there is an ln function in Excel. Much easier on your calculator. Just enter 20 IY. 1 plus or minus present value, 0 payment, 2 future value, compute in, and you'll get 3.8. The NPER function in Excel performs this. See the Excel file for examples. In the same manner, we can solve for the implied interest rate, and as with N, we can solve the general equation algebraically for I and plug in the values, or just enter the values in the TVM keys and compute IY. In Excel, use the rate function to perform these calculations. This is the end of the first part, Part A of Chapter 4. In Part B, we'll move on to annuities, perpetuities, and uneven cash flows.